Hi everyone. So far you've learned three methods for solving systems of equations, and in today's video we're going to use the foldable that you received in class, and we're going to first kind of review each method. So we've got graphing, substitution, and elimination. We're going to review an example of each, and then we're going to talk about how to choose the best method depending on the problem that you have. So let's go ahead and start by solving by graphing. So I'm going to go ahead and flip this one open. So you'll notice our directions here to say, or our directions say to solve the following system by graphing. And the nice thing about this is both of our equations are already in slope-intercept form. They already look like y equals mx plus b, which is going to make it really easy for us to graph. So let's look at that first equation here, y equals x minus 2. So I know for this equation that my b value, my y-intercept, is negative 2. So I'm going to start by plotting that point. My m, my slope, really there's a 1 in front of that x, so we know our slope is 1, which we can write as 1 over 1. So each time we move, we're going to go up 1 and to the right 1. And I'm just going to continue that. Now, I've seen a lot of us have been turning in papers where we just have a bunch of dots. Make sure you actually go ahead and connect those dots. I want a nice solid line when we're graphing. So let's see. I'm going to go ahead and connect this. And I've got the graph of my first line. So now I'm going to go ahead and graph the second line here in dark purple. And so for this one, I know my b this time is a positive 7. So I'm going to go up on the positive y-axis and find 7. Now my slope is a negative 2, which I can write as negative 2 over 1. So that means I'm going to go down 2 and over 1. And there I can see I've already located my point of intersection. I'm going to go ahead and graph this line. And then remember, no matter what method we're using, our solution is always an ordered pair. It needs an x and a y coordinate. So in this case, I can see my x coordinate, I go to the right 3. For my y-coordinate, I go up 1, and that is my solution. So when we're graphing, we're just looking for where those lines intersect or cross. All right, the next one we learned was substitution. So let's go over here. Now, if I'm looking at this problem, the nice thing about this problem is that if I look in this equation, y is already by itself. So now what I'm going to do, I'm going to take that, what y is equal to, and in my first equation, instead of y, I'm going to replace it with my 5x. Remember, when we said substitution, we always think about replacing. So now when I go back to my first equation, it's going to be 4x plus 2. Instead of y, we're replacing it with the 5x, and that equals 7. So now I'm going to multiply here. I have 4x plus 2 times 5 gives me 10x equals 7. I'm going to combine my like terms. I have a positive 4x and a positive 10x. So I get 14x is equal to 7. If I divide by 14, then I get x equals 1/2. Okay, now that I've got my x coordinate, I'm just going to plug that back in. So I know that y is equal to 5 times x. Well, in this case, our x is 1/2. So that tells me that y equals 5/2. Now remember, our solution has to be an ordered pair, so I don't want to leave my answer like this. I'm going to write it as an ordered pair, 1/2 and 5/2. All right, moving on. Our last method that we learned was elimination. And remember, for elimination, we said what we are looking for is our variables to be lined up. So x is on top of x's, y is on top of y's, and our constants on top of constants. And ideally, we want one of those variables to have coefficients that are opposites. So when I look here, we're actually in luck. My coefficient of y here is a positive 1, and here it's a negative 1. So this one is set up really nice for elimination. So now we're going to add vertically. So x plus x is going to give me 2x. 1y, remember y plus a negative is the same as just y minus y, so those are going to cancel. And then I get 12 plus 2 is 14. So now I'm going to divide by 2, and I get x is equal to 7. Once I know that, I'm just going to substitute it back into equation to solve for y. So now I have x plus y equals 12. Well, I know x was 7, so 7 plus y is equal to 12. I'm going to solve that for y by subtracting 7 from both sides. And I get y is equal to 5. Again, my solution is always an ordered pair. So my x is 7, that goes first, and my y value was 5. So that's how we do each of the methods. So what I want to talk about now is, if I have the choice, how do I choose the best method for a given problem? So here we go. For substitution, we're going to use this when one variable is already isolated. Okay, and by isolated again, we mean by itself. So for an example, right, when we looked at this substitution example, we already had one equation that said y equals. So we knew that was good for substitution. Now, I'm going to make a note here. When I say one variable is already isolated, it can either be x or y. It doesn't matter as long as one of them is already by itself. Let me try to focus this a little better. I don't know if that's any better, but okay. So it could either be x or y. Now, for elimination, we're going to use this when our variables, I'm going to say, are lined up on top of one another. So let's go back and look at our elimination example. If we look here, remember how we said the x was already on top of x, y was on top of y, and our constants were on top of each other. Those were already lined up, so we were set up really nice for elimination. Now, our last one was graphing. Now, graphing, I would say we would use this when we're given a coordinate plane. So that's a clear signal that we should be graphing something. Or I would say when our equations are already in slope-intercept form. And hopefully my hands aren't in the way here. I'll move in a second. So we would use it when our equations are already in slope-intercept form. Right? That was our first example we did here. We noticed they were both in slope-intercept form, so it was really easy to go ahead and graph. All right, so those are kind of what we should be thinking through when we're deciding. So if we look at these problems at the bottom here, it says tell what method you would use for the following systems. So for number 1, I notice here that D is already isolated. It's already by itself, which is going to make it really easy for me to take this and replace D with it. So that's when we would use substitution. For number 2, I notice that my variables are all stacked nicely on top of one another. So x's are by x's, y's on top of y's, and my constants are lined up. So here I would use elimination. And then lastly, my 2 equations down here, I notice those are in slope-intercept form. So ideally the problem would have a coordinate plane, and I would just use graphing to solve that system. So hopefully this provided a nice review for you and gave you some help on deciding when you should use each method, and you'll be able to practice with this tomorrow in class. Thanks for watching.